Welcome to this video on nested data type in ClickHouse. A nested data structure is like a table in a cell. The nested data type is quite rare in columnar data stores, but ClickHouse has excellent support for nested data type. The nested data type can be used to store semi-structured data in a structured table. This is an example of how a nested data type will be stored in a table. So in this table, we have two columns, ID and details. As you can see, the details column is of nested data type and it has three subcolumns. I am going to create a table called nested_example and we have two columns, ID and details. ID column is of 16-bit integer data type and details is a nested column. Within the details column, we have name, age and height columns. So these three columns are nested inside the details column. Let me insert a row of data in this table. While inserting the data, the values for the nested columns are inserted as arrays. So this value will be inserted in the ID column, and this array consisting of string A and B will be for the name column, and this array is for age column, and finally this array is for height column. To read the data from the nested columns, we can use the dot operator. So we will have to specify the nested column name followed by the dot operator, and then it is followed by the column name within the nested column. In ClickHouse, single level of nesting is supported by default, but we can have any levels of nesting by tweaking the settings. So this is about the nested data type in ClickHouse. Hope you learned something useful, and thanks for watching. Welcome back. In this video, we will cover the data types in ClickHouse that can be used for low cardinal data. Low cardinal data has very less number of unique elements in it. In other words, the values repeat frequently in the dataset. In ClickHouse, we have two different data types called enumerated and low cardinality, which can be used to store columns with low cardinal data. Using these data types can provide significant speedups while reading and storing the low cardinal data. The enumerated data type consists of named values, and low cardinality data type is a superstructure on top of other data types that can include string, date, datetime, and numeric types, excluding decimal data type. Let us look at an example for each of these data types. We will begin with enumerated data type. We have seen that the enumerated type consists of name values, where the names are strings and the values are integers. Enumerated type can hold 8-bit or 16-bit integers. Let us begin by creating a table with a column based on enumerated data type. This is the table name, and we have only one column called column 1 consisting of enumerated data type. While declaring the data type, we should also provide the list of accepted named values. So this column can hold only the values specified here. After creating the table, let us insert some data into the table. While inserting the data into the enumerated column, we can either insert the declared names or the numeric values. After we had inserted the data, let us read the data from this table. Although we had inserted a couple of numeric values, while reading the data from the table, the corresponding names are displayed. After this, let us try to insert a value for which we don't have a name declared at the time of table creation. But when we read the data from the table, it will throw an exception since the value is not declared at the time of table creation. Let us now move on to the low cardinality data type in ClickHouse. We have seen that this data type is a superstructure on top of other data types, and it automatically applies dictionary encoding to the values that are present in the column. So at the time of reading the data, the dictionary encoding is used and the data retrieval is made faster. As an example, let us create a table called low_cardinality, which has only one column called column 1. This column is originally based on string data type, but we are going to apply low cardinality data type on top of the string data type. So this is how we declare the data type for low cardinality data type columns. Unlike the enumerated data type, we are not required to declare the list of accepted values in the particular column. Once the data is inserted, we have read the data from the table. So this column stores the strings internally, but the data type will be low cardinality, and internally we will have a dictionary coding for all the unique values that are present in the column. And while reading the data, it will provide considerable speedups, and this speedups can be evident in case of underlying data has very less number of unique values and we have stored a large number of rows. So this is about enumerated and low cardinality data type in ClickHouse. Thanks for joining and see you again. Welcome back. Let us look at the data types in ClickHouse that can be used to store geographical data. In ClickHouse, we have point, ring, polygon, and multi-polygon data type that can be used to store geographical objects. A point is the most fundamental object in geometry, and it models an exact location or coordinates in space. It has no length, width, or thickness. In ClickHouse, point data type is used to store points that are represented by x and y coordinates. Internally, it is stored as tuple consisting of a pair of 64-bit floating point number. Next is the ring data type. Ring data type is used to store simple polygons without any holes. Polygons are two-dimensional and are closed shapes that are formed by 3 or more straight lines. In ClickHouse, a ring data type is internally stored as an array of points. Let us move on to the polygon data type in ClickHouse. This data type is used to store polygons with holes. As you can see, similar to the one that is displayed here, the data is internally stored as an array of rings in polygon data type. Finally, we have the multi-polygon data type. As the name suggests, this data type is used to store multiple polygons. In ClickHouse, multi-polygons are stored as an array of polygons. Let us look at an example for each of these data type. In this example, I am going to create a table called geo_example. It has 4 columns, and the first column is for point data type. The second column is of ring data type. The third one is of polygon data type. And finally, the fourth one is of multi-polygon data type. After the table is created, let us insert some data into this table with appropriate values. In this example, this particular tuple consisting of values 7 and 7 is for the first column, which is of point data type. The next value, which is an array of tuples, is for the ring data type. The third value, which is an array of rings, is for polygon data type. We have 2 polygons here, and the second polygon is enclosed by the first polygon. And finally, this is the value for multi-polygon column. The first value represents a polygon without a hole, and the second one is a polygon with holes. Let us insert this data. After the insertion, let us read the data from this table. So we have the inserted data here. So this is about the geodata types in ClickHouse. Thanks for watching and see you again. Welcome to this video lecture on map data type in ClickHouse. Map data type is used to store key value pairs in the table columns. The key serves as unique identifier for the value associated with it. A key can be of any of these data types that is displayed here. This includes string, fixed string, integer, low cardinality, date, datetime, and enumerated. Note that some of the data types like floats, decimals, etc. are not supported. The values for the keys can be of any arbitrary data type, and let us look at an example for the map data type. I am going to create a table called map_example. It has only one column, which is of map data type. While creating the table, we will have to declare the allowed data types for the keys and values for the map data type columns. Here, the keys are 16-bit unsigned integer and values are string. After the table has been created, let us insert a row of data into the table. So 1 is the key here and hello is the value. The keys and values are separated by a colon. After the data has been inserted, let us now read the data from the table. To read the data from the map column, we will have to specify the column name followed by the key in the square brackets. This will return the value for the associated key. If the key is not present in the column, 0 will be returned. So this is about the map data type in ClickHouse. Thanks for watching, and I hope you learned something useful.